Hello there, welcome to part 10 of learning as much as we can possibly learn from VisionOS Documentation by Apple. Here we have a next piece of sample code for ARKit. It's called Incorporating Real-World Surroundings in an Immersive Experience. Create an immersive experience by making your app content respond to the local shape of the world. Here in this application, scene reconstruction helps build the gap between the rendered 3D content in the app and the person's surroundings. Use scene reconstruction in ARKit to give your app an idea of the shape of the person's surroundings and to build your app experience into their world. Immersive experiences, those that use mixed space styles, are best positioned to incorporate this kind of contextual information. Scene reconstruction is only available in spaces and isn't as relevant for the full space style. In addition to providing a 3D mesh of the shape of different nearby objects, ARKit gives a classification to each mesh face it detects. For example, it might classify a face of a mesh as being part of an appliance, a piece of furniture, or structural information about the room, like the position of the floor, the wall and the floors. The following video shows virtual cubes colliding with the scene reconstruction mesh, which makes the cube appear to land on a table. Wonderful. Next, let's configure a scene reconstruction session. Scene reconstructions require the ARKit session, the authorization type, world sensing authentication authorization type, and corresponding usage description that you supply in your app info plist. The following starts a session and processes updates as ARKit refines its reconstruction of the person's surroundings. Here's where we have a reality kit. We have a content. We're going to add a content setup entity. Next, here's a task, some data providers ready to run. And here's another task, process hand updates, process session events, process reconstruction updates. And here's a gesture with the cubes. Let's take a look at that in our code. Of course, this is our immersive space. Here's our button. We'll open up and we'll place these cubes. Here is the cube data. Code. Here are some entity models about hand tracking and how we can make collisions happen. We can take a look at this shortly in the next piece of our documentation. Add real-world interactivity using collision components. You can make rendered 3D content more lifelike by having it appear to interact physically with objects in the person's surroundings, like furniture and floors. Use RealityKit collision components and physics support to provide these interactions in your app. The generate static mesh from method bridges between scene reconstruction and RealityKit physics simulation. Warning: be mindful of how much content you include in immersive scenes that use the mixed style. Content that fills a significant portion of the screen, even if that content is partially transparent, can prevent a person from seeing potential hazards in their surroundings. If you want to immerse a person in your content, configure your space with a full style. For more information, see creating full immersive experiences in your app. Use the low priority tasks to generate the mesh. Because generating them is a computationally expensive operation, the following creates a mesh entity with collision shapes using scene reconstruction. Here is our process reconstruction updates async function. And here we will await an update from the scene reconstruction anchor updates. This is probably a async sequence of some sort, and we go forth and do updates and grab shapes and add entities and make them collision components and give them a physics body component as well, and these updates as needed. Scene reconstruction mesh only supports physics body mode static, physics body component mode. Each object in the scene reconstruction mesh updates its original origin from anchor transform information independent and requires a separate static mesh because ARKit subdivides its representation of the world into multiple distinct sections. Display scene reconstruction mesh during debugging. People using an app that leverages scene reconstruction typically don't need to see a visual rendering of the scene reconstruction map mesh. The system already shows pass-through video in an immersive experience. However, temporarily displaying the scene reconstruction mesh can help while you're developing and debugging your app. In Xcode debugging toolbar, choose Enable Visualization button and select Collision Shapes because each element of the scene reconstruction mesh has a collision component. The details of the mesh appears in debugging visualization. For more information, see diagnose issues in appearance of running an app. Let's take a look at that pretty quickly. Here's the button, and here we can look at collision shapes. That's right down here, and this is the first one, the debug visualizer. Here in the app, we can try to run it, but I apparently has a bug that causes this app to fail. Here we place the cubes and we crash because it's somehow invalidated. Also, there is the issue of having hands as well, so that's another issue. So we can't run this app, unfortunately, to get more information. But here we have learned a little bit about how to work with a scene reconstruction mesh for AR kits in a mixed reality setting. With that, I hope you enjoyed this video, and we're gonna move into more information about AR kits in the next video. Thank you very much. I'll see you in the next one.